I think since we're not doing a group app, instead of spending that last 20 minutes on our app, we could open it up to questions. So you teach and then you say, does anybody have any questions? Anybody want to add to it? And then, get everybody's input.
That, and I think we should keep it open. Like, somebody's going to present, but it does not mean that it has to understand everything on its own,
right?
On his or her own. So if, for example, you're teaching and have a question on what's going on, like how something is going to work inside, like the job, like Rebecca has some job experience maybe, or Chris or whoever, we could use Slack for it, like just ask a question, and so that doesn't feel like I'm going to teach and I'm going to learn everything by myself and not going to get help, let's say.
Right. I think that's good. Also, we're supposed to be sharing links to resources we've found that week for the topics we're supposed to be focusing on. So that will help too.
Let's put those in Slack, in the
Scrum Slack channel.
The different Slack channel. What do we call it?
Scrum.
Scrum. So sorry, Scrum.
Okay, sounds good.
And we're recording now too, so.
Okay. Denise, do you want to go first, or do you want me to go first?
Either way, whatever you'd like.
Why don't you go ahead, since it's the first topic?
Okay.
Unless you want me to. I don't care.
So I put it together a video, and then it sounds like some of you have not been able to see it. I can probably just go through. We could either watch the video or I could just do it again in front of your eyes so you can stop me.
Well, we do a high level in front of our eyes and then we can go back and watch the videos.
If you want. Okay, excellent idea. Okay. So, let me see. These things, right? Okay. So, here we go. All right. Basically, I just said that I was talking. I wanted to show you where that collections come from. Okay, and that was kind of where I spent some time. And so the Java Development Kit is something that you download in order for Java to run on your system. And the component that holds the collections is in the JRE, okay? And then this is a really cool thing. And I will put this into, I'm gonna put this presentation or this PowerPoint into our Google Doc. You can just copy these links. I put links on all of these, and some of them you can't see because it's in the notes, but the links from where I got a lot of this stuff, okay? So there is, in Oracle Docs, there is this chart on this particular page, and you can click on any one of these colorful topics and it will take you directly to the documentation. I felt that was a really cool thing. So collections is down in the JRE here in the language and utilities. Okay. So what is an API? It's basically a set of functions and procedures which help you to create your application. Okay, that's just kind of a loose definition. And in my Linux class, I had to write a binary search. And if we spend all of our time writing searches and sorts and all kinds of different things that are utilities, we would never get to our application, basically. So in Eclipse, I went into, I think this program, and Here is an array list. This is part of the list collection. If you like hover over it, what I've learned is if you hover over it, come on, this comes up. It tells you where it lives. And if you click on here is the documentation. I came upon this purely by accident. If you go into this package, you can see that these are the this is the collection package, and there's comparers, all different kinds of things, but we're interested in this. If you click on that, you will see, if you notice this abstract collection, abstract list, abstract queue. All right, so we'll go to the tree and you'll see this in a hierarchy. And there's the abstract collection, and it tells you how they're kind of, who calls who and who's part of who, like how they're all connected to one of another, okay? So another thing that I learned, I'm gonna go back to my program, is that when you use a collection, obviously you're gonna have to include, or it's gonna ask you to import the library in which it came from. So another thing, so what I clicked on this, and then I got all of, I have the whole JRE right here in my thing, just kind of frightening because I don't know if I could actually edit this, which would be very bad for me at this point. But the Java utils right here, there are all of your collections in here. So abstract collection class, all of this is in here, and this is where the code actually lives. So let me just go back to this. Java is a collections, it is a set of collections, it's a framework and an architecture for manipulating and storing data. So why do you think they call it a framework? Well, I'm going to show you, and I'm trying to show you that. So I watched this YouTube, and I don't know, does the picture show up on here? I don't know. This YouTube where this teacher was overemphasizing how important it was to know the structure of collections and how important it was to understand if they were implemented, if they're extended, and all the nature of their relationship to one another. So here's collections right here, and it's part of the iterable. It's part of iterable and extends it. So so I'm not going to say that yet. Anyways, here's list, there's queue, and there's set, and there's many different methods underneath these that you can use that are utilities. So an array list is a part of collections, and will create you an array list object. And so there are many different ones, and I'm just pointing that out because some will be more useful to you in your program, and some will be less useful. Sometimes an array list is just what you need, and sometimes you need a hash table because of keys. There's different features for every single one of them. So down here, okay. So here is, I'm wondering, why was this guy talking about extending and implementing so much? It's been years since I've touched Java, so I had to remember that extends means, here, I should just read this because it was better. Okay. This is a review basically for me. And so inheritance is a huge concept for Java. So on the diagram, we have an airplane and a paper. Okay, arguably both of these, airplane and crunched up paper, fly. So they're both part of flying object, okay? Paper is a subclass of flying object, and flying object is a superclass of airplane and paper. So making this, so flying object is the parent, and these are the children, okay? So if you look at the two code blocks, how you say that, how you make a relationship where one is a child and one is a parent is by extending it right here. Extend flying object. So airplane is saying, hey, I'm a child of flying object. Well, the cool thing about that is that you can have code in flying object, or the parent, that is shared by many different classes that all have the same attributes about them, okay, that they fly. And so that saves you a lot of rewriting of the same stuff, okay? So I'll just read. Obviously, we know that, child, parent, grandparents, and then class, superclass, extending another superclass, and so on. So if you are extending something, the relationship is inheritance. They are related. They get each other's stuff. So when I say they get each other's stuff, they get to use each other's methods and classes within them, okay? And it will search for that. And I could provide you a video that helps you understand this concept more if you'd like. Okay. Oops. So implementing is a verb, and it's used with interfaces. Interfaces is like an abstract class, but everything in it is just a set of instructions. So in an interface, you can and go into any class and type implements, and you can implement many different things. So all of that is said to say that with implements interface, you don't have to be related to it. You don't have to have a relationship, to use the code inside of it. And that's important because it's, you'll see we couldn't use collections otherwise, right? So what the object class is, there's a class that's the highest class of all of the classes. It's kind of like the Adam and Eve of classes. Just as everyone that's born is related to Adam and Eve, all classes are related to the class object. The object class can store any other class, okay? So going back to this hierarchy that we just saw, and I just showed you in Eclipse, notice that the object is the top class. It's the Adam and Eve of all classes. And the abstract collection is implementing the Java util collections. What does it mean to implement something? It means that it doesn't have to be related and to use those set of instructions for everyone to use. And that's how that is possible, okay? So this is abstract list, which relates to this right here. You can see the array list right here is under list, as well as vector, which you can see here. So you're seeing how the structure is working. And just to point out to you, array list is implementing two things. Like I said, you can implement more than one library. So it has the Java util list. So the guy was saying, okay, you have to know if it implements or extends. Well, he's right. Array list implements list. It's implementing this list library, whereas list is an extension of collections. Okay, so you can see that there's queue here as well and set. So it's all in here. Okay. So this is a nicer, of course, I found this this chart afterward, and it includes not only the things that I just talked about, but it includes the map types as well, and you'll be able to have access to that. So I could go through this. Let me just see. Pretty much all of the collections can grow or shrink with data, as the data grows. Like an array list is dynamic, whereas an array, a primitive array, is not. And if you define a primitive array in your program, and you say I have 10 elements in it, if you try and hit the 11th one, it's not going to, you're going to get an exception error in that it's not going to allow you. So in this case, with an array list, it can go on and on. So I have 5 stars on array list because I like this the most. I like it over vector. They're very similar. Vector uses more space. It allocates more space than array list does, so it's more wasteful. It's older, and I don't know, the array list can, it's not synchronized, so you can use threading on it, where vector you can't, okay? So the linked list, I'm gonna move this. The linked list is, if you look down here, it's data that is chained together in like a line, and it has references before and after, or included in each little node of with the data, the reference to the next piece of data. And so the nice thing about a linked list is if you're doing a lot of inserting and deleting, and this might be really fast. It might be something you want to think about, because when you do a lot of inserting and deleting in an array list, you're going to have, it's based on index, it's going to have to re-index from wherever you are inserting something. So say you inserted, in the first third of the data, it's going to have to re-index all the way on down, and so that's going to take longer. But if you were doing that in here, all it would have to do is correct the previous and next reference for the data, and so that's much faster there. Now, searching a linked list would be slower than an array list, for sure. And the other bad thing about a linked list is it's not thread safe. So you have to lock it yourself. So if you wanted to use threading on it, not so much. There you go. So this is queues. If you look at the queue here, basically Sue is at the head. We got Joe, Bobby, and Sally. She's at the tail. So to get into line, it's in queue. You're getting in line. You're in queuing, and then to take them out of the line and to get the gasoline, like Sue just got out of line to go get. She's doing her gas now. She's DQ'd to get the gas, and so next would be Joe. So that's how that works. And priority queue is basically a queue that is sorted. And it says it's not thread safe, but they have another one, priority blocking queue, that is thread safe, so you could use that one instead. So there's lots of different queues. You can't have any nulls inside a queue, as far as I can see. And the difference, I did 2 videos, one on priority queue, or I don't know if I did them separately or together, but one on priority queue and queue. And the difference is that queue is not sorted, so however it comes in is however it is, and priority queue sorts it. And note that it sorts it, but it's not stored as sorted. So that means more overhead, okay? Hash map. This is basically the map section here. All of them have to have unique elements, all of them. My favorite one is the hash map. It doesn't mean any order for the data coming in. It's stored on the basis of key and value. So the nice thing about hash map, and another reason why I like it, is that it will not give you an exception if you ask for a key that you don't have. It just gives you nulls, so you just have to check for nulls. It's not synchronized, so I think you can put threads on this. And oh, here's a good point. Okay, so say I put in 10 elements, 1 through 10, and I decided to delete one, like number 6. It's not going to change or shift those other ones up. So 7 will still remain 7, even though there's a hole between 7 and 5. It'll just be like that, okay? It's unsorted. In a comment somewhere, I was watching a million different things. Someone said hash map is really good for headers in the REST API, which we we have to do this API thing for session ID. So, I mean, maybe the hash map is used a lot to store session IDs and pieces of information that you need to do to go out and search or for when you go out to the server. You can have one null key and many null values. So the other ones, okay, so hash table, let's compare that and said you can't have nulls or at no null key or at no null values whatsoever, you get a null pointer exception. Okay, so you would have to handle that in your code if you're going to use a hash table. It's synchronized, so that means that you cannot use threading on it. It's stored on the basis of hash code of the key and value, okay? And the tree map is basically just a sorted, which, see, hash table and hash map are not sorted. But tree map is sorted on key value, and it stores the data in key order. So that takes more overhead to insert something. Okay, so that was that. And then basically, I just went into, I did videos. Let me see if I can move this thing. Get out of this. Okay, so I did a few different videos on the different code for array list and such. I just kind of went through each kind of line. Let's priority queues really kind of fast. And so is the other queue. So here we have a little program. And basically, this is how you're getting this queue, okay? If you're wondering, hey, why does it say linked list? It's because if we go back to this, I'll show you really fast. This, the linked list, this particular queue is related to linked list and list, okay? So a queue is basically a line, a list of things. So that makes sense that it's using code from both of those libraries. So that's why that is. But so we are making a queue object, and it is getting it from this method. Okay, and so here, simply all you have to do here is, this is just a for loop, or a nice for loop that is going, starting at 10, and it's saying go down to 0, and I want you to decrement every time, okay? And the queue will look like 10, 9, 8, 7, 6, all the way down to 1. So the thing about queuing, a queue, there's this thing called peaking or peak right here, this peak method, and that is just basically looking at the head of the queue. And so that the head of the queue would be the first one, which was 10. Okay, and then the size is going to count how many elements are in there, so that's going to be 10 too. So this is just going to print out the size of the queue, which is 10, and then the head of the queue, which is 10, and then the following thing just pulled the queue, which deletes the first in line. So polling, queue poll is just going to pull out the first one in line, which would have been Sally or Sue or whoever it was. In this case, it's going to be 10. It's going to take away 10, okay? So then if you go ahead and print the size of the queue, it'll be now 9, and then it will be, it's going to, if you peek again, it'll be the 9th number, okay? So if you just run that, that's exactly what it's saying, okay? Size of the queue is 10, the head of the queue is 10, and then when after we peaked, or after we pulled one, it became 9 and such. But let's go quickly over to the priority queue, which is, remember, it's just sorted. It's just a sorted queue. So It's exactly the same code. It looks a little bit different by saying priority queue instead. I made this an integer. I'm wondering maybe I didn't try with a string, but I bet you could. I don't know. I bet you certainly could. Why not? You know, and so it's doing the same thing. So the queue will start out as 10, 9, 8, 7, 6, all the way down through to 1. And then the priority queue sorts it. So it's really the front is going to be 1 through 10 like that. And so we're doing the same things, the peaking. First, they took the size. Second, then we peak, which is looking at the first one. So the size should be 10 elements. Peaking the first one should be the number 1. And then if you, let's see, this is just to delineate, after you pulled one, then it should be just pull the queue, which deletes the first in line. And so the size of the queue should now be 9 elements, and the head of the queue should be 2. And that's what we got. So those are, I did those. Did I do the hash one for you? I think I did the hash one in video. I can do like every one of them if you want. So you can look at the different videos just to save time. Does anyone have any questions?
I was able to do a string for the queue.
Oh yeah. I why not? Of course. Yeah. Why not? I mean, it's pretty simple stuff, right? I think the hardest thing, I don't know why I got stuck on figuring out where this stuff came from, but I did, you know. So, but I guess I learned, you know, the basic concepts, whatever.
Have you talked about the trees? Did I miss that?
I can do a tree one. Let's see. Actually, I don't have a tree example. I can make a tree example and then.
No, that's fine. I just wondered if you had talked about it, but that's fine. I'm sure I can do it.
So there are 2 types of trees. There's the tree set.
Yeah, isn't it the one you have right here? It's like a set, popular cities. It's a tree set.
Yeah, just in front of you.
Oh yeah.
Just in front of you.
Hash
Line 8.
No. Just look in
right
front
there.
of your screen.
Right
like
there.
in the center.
Oh, yeah. Okay, so that's what I was going to tell you, okay? So there's a difference, a really big difference. Let me show you in this picture here. So there are sets that have a tree set, okay? So a set is like a bunch of numbers, like a set. You know, we use this in elementary school, like there is a set of, I don't know, different kinds of pop, or there's a set of, you know, numbers or whatever. So this is a set, whereas a true tree map is down here. This is a different kind of tree, okay? And that's part of maps. This tree, a map, this is sorted and it acts differently than the tree set.
Okay, so you did talk about both of them. You just integrated them with the other.
Right.
Okay.
This tree map and hash map, they all live in the same kind of hash table. You know, I didn't find much on identify hash map. I didn't find much on weak hash map. But basically the ones that I found that were most liked were hash map, this tree map, and this hash table. So, but they're different. Just know that there's 2 kinds of trees and they're very different. This is part of set type and this is part of the map. But okay. So I went through and made a video of this code here showing the hash set, how it behaves, how the linked hash set behaves, and then how the tree set behaves. And you can switch that very easily just by commenting that out.
Cool.
So I think, have I covered it? Any other questions? I think you guys are good.
All right. Thank you, Denise.
Yeah, I think that was a good overview.
Yeah, that was a great example. Thank you.
Yes, thank you. Okay, so let me do mine. Let me share my screen. So that was really helpful, Denise, because I spent my whole week on the threading. Okay. Can you see my screen? And
Yep.
Yes.
Yep.
but can you see the stuff over the top of it?
Nope,
Yes.
just the presentation.
Just the threads.
Oh, yeah.
Okay, good. Okay. Because I can see you guys over the top of it, and I'm not sure how to fix that. So, but I'll just leave it if you can't see it.
You can, if you have two screens, you can move it to the other screen.
I do, but
There's a minimize button on it. I just figured that out too.
Yeah.
On the pictures, on the photos, there's like a
Top
Oh.
right there.
oh, okay, that'll work. All right. Okay, so I'm talking about threads, runnables, and executors. And as I was trying to wrap my head around this, I came up with the analogy of threads are like your employees. Let's say you have a business, and you would be the main thread, and you start the business, or the main thread starts the main task, the main method, and you can do one thing at a time. But if you want to do more than one thing at a time, you need more threads or more employees. So threads are like employees. And you can hire temporary employees by creating new threads one at a time, or you can create executors, which is like hiring a manager with a pool of employees. So the benefits of the temporary employee is you don't have your employees hanging around all the time. If you only have one or two jobs, then you would just hire an employee temporarily, and then as soon as they're done with the task, they leave. The downside of that is every time you have a new task, you have to go out and hire a new employee, and so that adds overhead. I'm not sure this analogy is working very well, but anyway.
It
So
is.
threads are just the individual employees, and the executors are a manager with a pool of employees. And you need to give each thread a task. And to do that, you can hire a specific type of employee, like a taxi driver. So you would create a class of thread which extends thread, and every time you created a thread of that type, then it would do this one task that you set for it, and when it was done, it would leave. Or you can create a runnable. A runnable is a task for the thread to do. You implement runnable, and then you create just a generic thread and give it a runnable to do. Okay, so let's get into threads a little bit. So a thread is, oh, that didn't change it. How do I change it? Sorry. There we go. So a thread is just a thread of execution in the program, and you can have multiple threads running at the same time. You start with one thread, and then you can add more threads. Every thread has a priority. The default priority is 5. They all have the same priority, but you can add a higher or a lower priority to different tasks. And the program will prefer the higher priority tasks. It won't guarantee they will get done in the right order, but it will make it more likely that your high priority tasks will get done sooner. And then you can also mark threads as daemons. Is that how you pronounce it?
Yeah.
Okay, which means that your program can end while there's still a thread running. Normally, the thread has to finish before the program can exit, but with a daemon thread, it doesn't have to. All right, and so here is the life cycle of a thread. You create a new thread. And then you have to start it. So you create a new thread, and then to get it running, you start it, and it becomes runnable. And then it's running, and then you can cause it to wait for a minute by using sleep or wait. and then it can go back to running, and then at the end, when it's done with its task, it dies and goes away. Unless it is a thread that is in a thread pool with an executor or executor. I'm not sure if it's an executor or an executor. Okay, so let's talk about first runnables. Implementing runnables, you can create a class that implements runnable, meaning it uses the interface runnable. I'm glad you went first, Denise, because you talked about all of this, so that's awesome. And remember, this is like hiring a generic employee to do whatever task you tell it to do. So the runnable is the task, and that is the preferred method of doing it, implementing runnable, because then you have a generic thread. It's more flexible. If you extend class, let me come back up here for just a second. Oh, I didn't change it. I'm so sorry. I'm not doing very well with this PowerPoint presentation. Okay, so with runnables, you create a class that implements the runnable interface. And that's better than extending the class, because if you extend a class, you can only extend one class at a time. This makes it more flexible so that you can extend multiple classes at once. Okay, so let's look at implementing runnable. So what we're going to do is create a class that implements runnable, and then you give it a task to do. You need to override the run method in the interface. The runnable interface has the run method, and you override it and tell it what to do. And then in your main method, you can create a new instance of that runnable, and then you create a new thread, just a generic thread, and you give it this runnable to do, and you give the thread a name. And then you have to use start to get the runnable, to get the thread going. Does that make sense so far?
Yeah, it makes a lot of sense, especially the way you've laid this out.
Thank you. Okay, so you can reuse that runnable over and over and over. You only have to implement it once, but you have to create a new thread each time you want that runnable to happen. So you create a new thread, you put in the runnable. Oh, what happened here? So you create the runnable, you create a new thread, you put the runnable in and the thread name, and then tell it to start. Okay. So another way that you can do runnables is with a lambda expression. And I'm not completely sure what a lambda expression is, other than it seems to be a shorthand way of writing it. Instead of creating a class that extends or that implements runnable, you could just create a runnable. So here's my runnable, I named it task, and here is the task to do. It's going to get a name, I'm naming it, and then it's going to print out this line. So, and again, I have to give that task to a new thread. So I create a new thread. I create a new thread and give it a task, and then I tell it to start. And I can write this in a shorter way. I can just say new thread, give it a task, and start it all in one line. The only thing about this is it doesn't have a name. It's just a generic thread with no name. The computer gives it a name. It'll probably be thread-1, which is fine. Okay, any questions about runnables?
Nope.
Okay, so let's go ahead and look at extending class. That's the alternate method. Remember, a runnable is just a task. You can give it to any employee that you want to, or any thread. This is like creating a specific kind of employee that only does one thing every time. So To do that, you're going to create a thread class that extends class. And the thread class implements runnables, so you're implementing runnable in the background by extending class. Now, this is not the preferred method because it's less flexible. You can't extend other classes. And so you would only do this method if you were going to override more than just the run method. If you're going to override something extra, then you can go ahead and extend the thread class. Otherwise, just do a runnable with a generic thread. Okay, so let's look at how to do that. Okay, so to create a thread, or sorry, to create a thread class, see, I have my example thread class, and I'm extending thread, and then I give it a task to do inside the run method. So I'm overriding the run method and giving it a task, and then down in my main method, I'm going to create an instance of that kind of class and tell it to start. And I can do it this way as well. I'm creating a new thread. Okay, hold on. I've confused myself right here. This is, I've created a new thread and it's the type message thread and I've started it. If that confuses you, don't do it this way. Just you create an instance of the thread and then you start the thread and it will do the task that you have put up here. It always does that task every time you create that type of thread. And you would have to create a new instance of that thread every time you want to start it. Okay. And there are a bunch of different methods that work with threads, both when you're using runnables and when you're using a specific class of thread. You can tell it to sleep, which will cause it to pause for that amount of time. But that can throw an interrupted exception if the program ends before the sleep ends, so you need to catch that in a try-catch block. You can return the current thread and you can get information about that current thread. You can set the priority of the thread. You can set the name of the thread. You can get the name of the thread. You can set it as a daemon thread, and you can do a dump stack, which will tell you everything that's happened with that thread. That's helpful for debugging. Okay, so creating individual threads is not the preferred method of working with threads. It's cumbersome. It's much preferred to create an executor. This is considered higher level. And again, it's like hiring a manager and a pool of employees. So what happens is you create your executor and you create a pool of however many sized threads you want. And then each time a task is assigned to a thread, when it's done, instead of dying, it comes back to the pool and waits for another task or does the next task that's in the queue. And you need to be really careful to choose the size of your thread pool. It's like employees. If you hire 50 employees but you don't have enough work for them, then it's a lot of overhead to pay the employees when you don't need them. So, but you also don't want too few threads because then your tasks are going to be waiting around, your program's going to be laggy, and people are not going to be happy with it. Okay, so here is just a diagram that shows how the executors work. You submit a task to the executor, it goes into a task queue, and then as threads become available, it will be assigned to a thread in the thread pool, or a task will be assigned to the thread in the thread pool, and it will go do it, and then it will come back and grab another task and do it over and over and over. There's lots of different kinds of executors here. Executors here are just a few of them. You can just do a single thread. You can do a fixed thread pool, which you can specify how many you would like in your thread pool. A new work stealing pool, it creates as many threads are available or are possible at that moment. And then it will get rid of the threads if it doesn't need them. But wait, sorry, that's the new cached thread pool. I apologize. The new cached thread pool will create threads if you get like a really intensive section of your code. It will create a bunch of new threads, and then after 60 seconds, if they're not being used, it will get rid of them. Whereas a new work stealing pool, it creates as many threads as you have processors, and then the idle threads can break up jobs to create subtasks, so it can get the work done faster. Or you can do a new scheduled thread pool, which is capable of scheduling tasks periodically. You can say every 5 seconds, do this, with a scheduled executor service. I didn't delve a lot into the different kinds of executors. The one thing I did find is that when you're just starting out, it's a good idea maybe to use the fixed thread pool, just because if you make a mistake and write your code so that it creates hundreds of threads because your task is not ending before the next one is starting, then you will max out your system very quickly, and that'll cause a problem. So they suggested when you're just starting out using the fixed thread pool so that you don't run into that. But our textbook suggested the new cached thread pool. So you can look more into that if you would like to. So let's talk about creating an executor. So to do that, there's different ways of doing it. You can do executor here, or executor service, or there's a couple other things you can do, but this was the one that I found examples for. So you are doing a type of executor service, you give it a name, and then you create a new one with executors, and then the type of pool you'd like. And then the thing about executors is they won't stop by themselves. If you finish your program and you don't stop your executor, your program will just sit there and it will never close. Sort of like with a business, you hire your employees. If you decide to shut down your business, you have to let all your employees go. If they're sitting around in your building, then you can't close your business. So to shut down the executor, there's two different options. You can do shutdown, or you can do shutdown now. Shutdown will stop as soon as the threads are done with what they're doing. Shutdown now stops everything immediately and throws an exception to say these are the tasks that were left over that didn't get finished. So, whoa, sorry. So the suggested way from Oracle to shut down gracefully is to first say shut down, and then if that doesn't shut down, that means you have threads still running, and so you give it a little bit of time to shut down, and then you tell it to shut down now. And then that's going to throw an exception, so you catch the exception, and just in case it didn't shut down, you tell it really shut down now. And you need to put that anytime you start an executor, you need to close the executor before you close your program. Okay, so how do you give tasks to the executor? You do it with the submit method. And you can submit several different things. You can submit just a task, and you don't have to have a runnable. You can just say, this is what I want you to do, go do it. Or you can use a runnable, like we did with the threads. You can reuse the runnable over and over and over, and you just submit the runnable name. Or you can use callables and futures. Okay, so with runnables, you tell your employee to go do something, and they do it, and then they leave, or they go back to the pool. But what if you need them to bring you something back? In order to do that, you need a callable. So the callable is like a runnable, but it has a return value, but the callable won't wait around for the return value. So instead, you have to use a future to go get it. So callables. Here is an example of callable. Just like the runnables, you can do it just inside your main method, or you can do it by creating a class that implements callable. And you need to tell what the return value is going to be. And then you tell it to do something, and then it needs to have a return. Just like having to override run, you have to override the call method when you are doing a callable class. So it's inside the call method that it's going to return something. Here's another example of a callable. This is one that is not a callable class. It's just a callable that's been created in the main method. So again, you have to say what the return value is going to be, and then you tell it what to do. This is written in a Lambda expression. It's got the, instead of saying method, well, anyway, it's just a shorthand way of doing it. Here is, you're not submitting anything with it, and this is the method that's going to happen. So instead of doing the call method, it just automatically does that for you. So you just have to have a return value. And because I used sleep, that's why I've got the try-catch block around it, because you always have to put a try-catch block to catch the interrupted exception if you are causing it to sleep at any point. Okay, so to catch the callable, you have to use a future. So a future, hold on just a second. Okay, so the future goes out and grabs the callable return value, and you want to, well, sorry. Where did it go? I don't know why. This is my mouse, like, I'm still learning how to use it. Okay. So a future, to use a future, you tell what kind of return value you're going to be getting, and then you give it a name, and then you submit to the executor. So we have executor submit, and then this is our callable that is going to return the value. And then we're going to use future.get, and that will put the results into the future. I was running out of time, and I'm just getting to the parts where I'm not completely solid on it, so I apologize if I'm not explaining it very well. But you have to use future.get to get the information, but you have to be careful because this blocks the thread. If you say go get the result and the callable has not finished its task yet, then it will sit around and wait and wait and wait until it gets returned. So don't use future.get until you are ready for the return value, because it will sit around and wait for you to call for it, and it just keeps it, it just holds it, and then when you ask for it, it will give you the return value. Another thing is if the callable never finishes its task and it's just sitting out there and you close your program, it's going to throw an exception. And so you can put a timeout to make it not just wait forever. And to do that, you would do get, and then you say the time amount and then the unit of time that you're using. And then because get is blocking, you can check and see if it's done before you get it. So if you do is done, then it will check, it will return a Boolean value, true or false, and if it's done, then you can go get it. Okay, and when you're using the executor, or the executor, you can use several different things to do several callables at once. You can use invoke all or invoke any. And what that will do is, if you do invoke all, it will do all of the callables that are in your list of callables, and then it will return every single return value when you do future.get. Or you can do invoke any, which will just return the first value that gets returned. So task 1, 2, and 3 are happening, but task 2 gets done first, and so you will get the return value of task 2, and you'll never get task 1 or 3. So that's an option for doing multiple callables. Now, the problem with working with threads is multiple threads is that you can create race conditions, which means that, let's say you're having multiple threads change a variable, and they all get to the variable at the same time, and they're overriding each other, and you'll lose information. And so you have to be careful not to have race conditions. So there's a bunch of different ways that you can deal with that. You can use synchronization and locks, and Denise talked a little bit about that. I did not delve very much into that, so if you would like to, I've got some resources that you can look into. Another thing is using atomic variables, which means they're safe for threading. And so if multiple threads get to the variable at the same time, they will, I'm not sure exactly how it works, but it makes it so each one gets their turn to change the variable, and nothing gets lost, nothing gets overwritten. Synchronization and locks block the threads. They have to wait their turn to change it, but the atomic variable doesn't block. So this is the preferred if you can use it. Let me show you a program that can you see that?
Yep.
Okay. So here is my program that uses all of them, but here is my increment counter. So to do an atomic integer is what I'm using. I've got an atomic integer, and you have to create a new atomic integer with a value. And then in this, I'm going to increment it. And to use an atomic integer, you have get and increment is one of your options, which will let the thread get the value that is currently there and return that value, and also increment it at the same time. And then value just gets the value. Get just gets the value. It doesn't increment. So get and increment is one option, and just get is the other option. And so in my main class, well, here's my thread class, and it's going to grab the counter, the atomic variable, or the atomic integer, and it's going to increment it. And then it's going to return the answer back well, it's going to print it out here. So I'm just going to save the value of that increment counter and print it out so that you can see that it does go ahead and go in order. And each of my different types of threads will do that. So here's my runnable. It's implementing the runnable. And it also is going to increment my atomic integer. Here's my callable example. It implements callable. And again, it's going to increment my counter. So here's my main class. That's going to, first it's going to call all of my callables. Then it's going to do my thread example, which extends thread. And then it's going to do my runnables. And then it's going to get my futures that I have floating out there. And then it will shut down my executor, which I created up here, right there. Okay, so let me go ahead and run that. I can't see the top of my screen. So if you, oh, it didn't work. Interesting.
Sometimes you have to run it from the sidebar.
Run it from the sidebar.
Well, I think you're a different one.
Oh,
you're
there
on
it
that page.
Okay. So here are my, the ones, the callables that I did with the executors. And notice my atomic counter is going up in order. If I didn't have an atomic counter, it would be all over the place. The numbers would be not in order. But because I have an atomic integer for my counter, it does do them in order. So here are my callables, and these are the results of my callables. Here are my threads, and the runnables are in here somewhere. Anyway. Does anybody have any questions?
I have a lot of questions.
Okay, hopefully I can answer them.
Okay, I tried to really quickly get up to speed on threads, and I only looked at threads because that's all I had time for, and I still didn't completely understand it. Can you bring your presentation back up again?
Yes, I can. I figure out how. Hold on.
So I feel a little bit overwhelmed with all the information.
It's a lot. I shared the presentation on our Google Drive, but I'm happy to answer the questions too. Tell me, where do you want me to go to in the presentation?
All right, let's talk about the executor situation.
Okay.
The code for that. Let's go down to the code. Okay. So first of all, do I have to use an executor?
You only have to use an executor if you don't want to call each thread one at a time. You can create a new thread at any point and give it a task and set it to start, and it will go. You want to have a thread pool where you have a set number of threads that are always available to you. That's when you use an executor.
Okay, so I kind of do want to do that, so that is that managing all, like say instead of picking one thread pool. So is one thread pool, okay, how many threads are in a thread pool?
Okay, so you decide how many threads in a thread pool. You start with your main thread. That doesn't count as your thread pool thread.
Okay, so just for everybody else who hasn't had a chance to look at any of this, Java will assign one thread to Java, and that is in your main. So main is getting one thread already automatically, okay?
Yes. then, sorry, you have your thread pool, and if you choose to put one thread in it, then it will have one more. So you'll have your main thread, and then you'll have your thread pool thread.
Okay, so essentially it's 2.
2 threads, yes.
Okay, so if I put 2, then there'd be 3.
Yes.
Okay. So knowing that, you're telling me, because I've watched these guys do the code, some of the code, and what they're doing is they are using runnables, or they're using the, they are extending something, they're extending the, I forget, what do they extend?
Thread.
The thread, they extend the thread. Mm-hmm. Okay, well, and I understand that runnable is better. Runnable is better because you're doing, the relationship is not a relationship of inheritance. Right. You're basically losing all my words for some reason. So I mean, it's just a set of code that gets run. So that's very different than inheritance.
So when you comparing making individual threads by extending thread or by implementing runnable and just creating a new thread, that's sort of like the basic simple way of doing it, but it's not the preferred way of doing it, because then you're having to manage your threads all the time.
Right, okay.
An executor is a much better way of doing it, because then you have your size of pool. If you choose to do, oh, my stupid mouse. If you choose to do like a new cached thread pool, it will make as many threads as you need in the moment, and then it will get rid of the threads that you don't need later.
Okay, which one was the preferred one out of there again?
There isn't really a preferred one, other than if you're beginning, they suggested starting with a new fixed thread pool, just so you don't crash your program by accidentally creating way too many threads.
Okay.
But I'm guessing that when we get to making our app, that might not be the preferred thing to do, because if you only have 2 threads, then you can only do 2 tasks at once. And if you need to be doing 5 tasks at once, then 3 of those tasks are going to have to wait until the other tasks or the threads are done. So you might need 5 threads, but you also, if you don't need 5 threads most of the time, having 5 threads sitting around costs overhead.
Right.
So I don't know well enough to tell you how many the ideal amount is, other than they said, like, look at how many different tasks are going to be running at the same time and try to have enough for that. But you don't want like 50 threads sitting around if you don't need them. So possibly the new cache thread pool is a better option. Our textbook, the Doing More with Java, that was the one that they demonstrated. So
okay, so my next question is the executor. This callable in future, do you have to use that?
You can only use callable in future with an executor. You can't use it with just making your own thread. It's an extra thing that you can do with an executor, but you don't have to. You can use a runnable. So you would use a runnable if you want to say, go do that. But if you want to say, go do that and come back and tell me you did it, then you need to use a callable.
Oh, so if you want any response back.
Right, you have to use a callable. So,
okay. So runnable, just
like a
runnable. Let's think of it, something that would work with that. Runnable is like you sent your employee as they're leaving for work to drop off something somewhere, where a callable is the employees working during the day, and then you sent them to do something, and then they respond saying if it worked or not, something like that.
It can be like that. It could be like the employee comes in and you say, go clean the bathroom. They don't have to report back that they cleaned the bathroom. You're just assuming they did it. Or go set this over there. Or go write a report you would need to get back. Just if you're saying, go do something, and when you're done, you're fine. Go do the next task. But if you're saying, I need you to go get me this report, or I need you to write me a report and give it to me, or I need you to go buy something and bring it back, then you need a callable.
So,
It
for
needs
example,
to return something. Go ahead.
So, for example, if you're planning to create an app, a callable will be needed to see the input that we are giving through the touch screen, and in the meantime, run alongside anything else we want. But we want a callable for an input because we want to read what the user is doing, and we want it to tell us what is happening.
Yes, that's exactly right. So if you need a return value, if you're getting information and you need that information, you would need to use a callable. And you want it to do asynchronously so that you're not blocking everything else from happening at the same time. Because you can say, go get me that information and bring it back, and then you sit and wait forever. But if you're using a callable, you don't have to wait. You can, in the future, get that value when it gets back.
Okay, awesome. That makes a lot of sense now.
Okay. Any other questions?
Did you keep track of all the places that you found sources?
I can give you a list of all of my resources. I have them. I didn't write them down, but I can just put them in Slack. A lot of them were the ones that he gave to us. The one that I liked the best, that I felt was kind of I was able to understand it, but it also had enough information, was the winterbee.com resource that he shared in his video to start out threading. So, but I will definitely share those.
Okay.
Thank you.
Great job, Tammy.
Thank
So
Yeah, thank you.
just a couple thoughts
Thank
I've had. Just like, forgot his name, our teacher. Anyways, he had an issue with his recording, and you would hate for that to happen, but it is also a possibility. But if that happens, you may want to re-record what you did, Tammy. I'm hoping that it doesn't ever happen, but you know, if it happens to the teacher, it can happen to us. And then also, the only nice thing about our little recordings here is that you also get the interaction. So I don't know kind of what he is wanting as far as our professionalism. But
Yeah, so you are recording this. Where does that recording go? Can you share that with us?
I will share that. So kind of depends on the hour. It will take a little bit of time to render, and then it will save to my computer.
And,
So I can either share it to like Google Drive. Kind of depends on the size of the file. I can email it, or I can share it on Slack. Maybe two places might be great, so that you can actually download it and then share it in your familiarity or your professional stuff that we have to turn in.
Okay.
And could you actually stop recording? And I would like to add a couple more things. So since we have to send the familiarity reviews singularly,